Page 126, number 23. Determine whether the function is 1 to 1. If so, sketch the graph of the inverse. Okay, now I gave you a hint is to make a table of values and use the definition of reflection principle. So the idea is to first check to see if the function is 1 to 1. And how we do that is if it passes both the horizontal and vertical line test. So that means the function itself is continuous and is a function. The original relation is a function, and its inverse is also a function. So we're told this is a function. It passes the vertical line test. But does it also pass the horizontal line test? And the answer is yes, it does. So that means we can sketch the inverse. So what we want to do is use the reflection principle, which says that the points A and B of the function, and you reverse them, B and A are symmetrical with respect to the line y equals x. So in other words, when we sketch the inverse, we should be able to draw the line y equals x, the identity function, and the two functions, the original one and the inverse, should be a mirror image of each other across that line. So an easy way to see that is to make a table of values for the function. So we'll do that first, and we'll get these values right off the graph that was given. Now, mine might not be completely accurate. You can use the one in the book and count the points a little better. So I see that at -5, I'm at -3. At -2, I'm at -2. 0 is at the origin. Then we have 1, 1, 2, 2, and 5, 3. Okay, so then to do the inverse, what we're going to do is we're going to switch x and y, because what happens with the inverse is the domain is the range and the range is the domain. So we are going to have an xy table that looks like this. So let me write that, switch x and y. So now our x's are going to be -3, -2, 0, 1, 2, 3. And our y's are going to be -5, -2, 0, 1, 2, and 5. So now we can plot those points, and we'll have our inverse function sketched. And you'll see what I mean about being reflected over the line y equals x. So at -3, we're at -5. At -2, we're at -2. At 0, we are at 0. At 1, we're at 1. And at 3, we are at 5. So really, what we have here is our cubic function. And that's not too bad for the pen set. But what you can see is if I were to draw the line y equals x, these two are symmetrical over that line right there.